Right. Obviously, the last time you saw my very quiet but manufacturing video of the prototype PCB and showing you what it's replacing really. Now this is all of the connections that were required before to do that test on that breadboard, and obviously it's now coming. It's going to go into that. What will be considerably easier because there's a lot of connections that were going wrong for me. This breadboard's seen better days, as I said. I think I melted parts of it. Part of my testing of the heating pad definitely did that, even though it only drew a little bit of current. But the next thing I'd want to do is basically show you going through assembling it, soldering, etc., or trying to. One of the things I'm having with this type of copper clad board, commonly used, is the glue isn't that great. So when you stick quite a few hundred degrees through it, it delaminates almost instantaneously sometimes, or pops, and then you might find that you've broken the pad away from the board. Hopefully that won't happen. I have some lower temperature solder, so I'm going to try dropping the temperatures down because I always run quite hot. It's just quicker. But before I do that, I'm just going to slide that across and we're going to talk about power. Now, I'm going to get the whiteboard out. Oh, probably should slide this across with the whiteboard. Let me just try that. There we go. Now, hopefully that's in frame and not reflecting to Kingdom Coming back. Does that all the time. Hopefully you'll be able to see this. I know you've got a nice bead of light going up it, but no, my apologies. Power's a very important one, especially when it's sorry, I rephrase that. How long do we want it to run for? From what I've seen, other people doing this, it could take about 1 to 2 hours to do the round trip. But it depends on quite a lot of factors at the time, really. How much weight you've got, how big your balloon is, have you kind of balanced them out right, what the temperature is. Those are the sort of factors that change how long it's going to take to get up to its altitude and come down. If you get it wrong, it might not actually get to the bursting altitude either, so that's why there's a additional wire cutter. So first thing you need to do, first thing I did when I was trying to work out power is how much power everything's taking. Now, that took me a little bit of time, but what have we got actually? I'm going to call, excuse me. Now, all the components on here, I'm just going to refer to as like the sensor board or the compute board, just for simplicity. So you've got the compute board, we've got the GoPro, we've got the, I don't know if you can read that, heating pad. Now, I was never great at writing neatly. What else we got? The wire cutter, I guess, is another one. That's hopefully won't be needed for too long. I think that's it. So, from my measuring, the computer unit, I've downclocked because it's 600 megahertz. You can overclock it to a gigahertz. Downclocked it 25 megahertz just for the power consumption aspect. So all of the items on this board use 0.12 amps amp power. What would put per hour? I only do it once though. GoPro, gonna obviously need to run this quite a lot of time. The GoPro has its own battery, but looking at the size, it's about 600-700 milliamps. It's probably not going to last an hour. Now, I ran some tests, like recording at like HD 60 frames, and on average, it was using about 0.5 amps. The heating pad, now they are kind of a bit strange. The colder, the hotter it is, it changes the resistance, and then changes how much current it wants to draw. But we'll just call that 1. The wire cutter, Paul's still working on that one, but that's going to be quite an insane amount. The thing is, it's going to be needed for like maybe 10 seconds tops, 5-10 seconds, but it's probably going to. I'm going to actually leave that out for now because I have an idea for what I actually have already figured out an idea for. So, if we want to run this for, I know people say 1 to 2 hours, but let's say this falls in the field and I can't find it for ages, or I'd always like to have extra margin. Now, there's other reasons for extra margin. One of them is the batteries that I've got here don't like cold that much. They will drop the voltage, most likely the capacity, the colder they are, so you won't get as much out of them. And now I've completely forgotten the other thing. Oh yeah, the other thing is I'm looking at running at 3.7 volt cells, a single cell battery, and I'm going to have to get it to 5 volts. To do that, you have a loss, probably about 10 to 12%, depending on the component you're using. I think I picked this here, because it's got a good. It's not a high loss. I think it's more 10% or 8%, but let's assume it's 10 to 12. And yeah, well, let's say we take 5. I don't know this figure from 5% off for temp loss. So I want to run it for 3 hours best case. So I'm just gonna run out of whiteboard space and just draw a line to make it easier. So we're at 3 hours. So what's all this add up at 5 volts or 3 hours? Now math-wise, stand by. I feel like I'm missing something. I am. I'm glad I did. We've got the SATCOMs. Now SATCOMs won't actually be using it'll be using its own converter, because I'll just be connecting it straight into there. That can use 0.1 to 0.4, I think it was, amps. Okay, let's take worst case of that. I think it's 0.4 when it's transmitting. 0.4, 0.9, 1.9, 2.02, if my math is correct. So we use that. We need that much per hour. And we'll run it for 3 hours, so we need okay, and let's assume we have some losses at play here. Let's say it's 10%, because it's easier to do math in my head for that. So let's say, well, it's 15 actually, but let's say it's 20. Let's make it worse. Yeah, I think that's a good idea. So let's just round it up to 20, because I'd rather be overcompensating. And under 10% of that is 0.6, 1.2, say 7.26. So okay, so we need, hypothetically, something that has over 7 amp hour of storage at 3.7 volts, because of that conversion loss. Might be more, might be less. Maybe you just round it up to 10. That will give us quite a good degree of margin. Now the reason I say that is because I actually have something ready for this. So we need a 10 amp hour. Now the wire cutter, I don't want to run it on the main battery, because I'm concerned that in essence we're just going to create a short circuit. It's going to get something really hot. Now components, not the best to do that with. Some of like a MOSFET, it could get locked on or burn its antenna. If that happens and you have it on the main battery, it's going to turn into a massive toaster. Well, the wire will. Also, you run out of power. So I was thinking about putting its own little battery, and then if all goes wrong, it doesn't matter. It's just going to just nerf a smaller battery. So 10 amp hours. Now, as I say, I have some preparation for this. Here's a 2-cell 5.2 amp hour. What I've done is I've delaminated the 2 cells, reconfigured them into this. Very interesting mess. Now, I don't want to go too much bigger, because this is quite heavy. This is 220 grams. It's probably going to be half the weight of the thing is going to be a battery. Now I've tested it. It's 9.7 amp hour. Well, it's probably 10 amp hour, so it's certainly not a bad cell. And then I've stuck on a XT60 connector. Just very useful, good connectors. And for the wire cutter, I've got a 600 milliamp hour single cell battery. And then I've just done the same. Now, obviously, if you get cheap batteries, what I have, the C rating can be questionable. Capacity can be questionable. That's why, in this case, I've measured the capacity, checked it. C rating, I don't need 80 times 5.2 amps. I need I probably need, well, 0.5 C. So it's very good to run them low C. Now this one is a 25C single cell battery. So 0.6 times 25. Math is not my forte now. 15 amps output this could do at that. Well, will we get that? I don't know. I have tested also the capacity of this. It's good. So for the 5 to 10 seconds we need, this should be fine. But it's very important you work out your power needs. So we should have probably 3 to 4 hours best case in it. So plenty. I could always downsize it in future versions. Okay, let's get to the other whiteboard and zoom back down. Now, assembly time. Let me turn on the other soldering iron. That's good. Components we've got to play with, and I pulled them all off the breadboard. That took ages. Now I have the GPS, but it's been stubborn. So let me see about getting that off. It was not wanting to come off. There we go. GPS. Now, how I envisage this is, what you probably don't know is, this isn't actually affixed to this board here. This is going to sit with this SATCOMs guy on top, and then these guys are going to be down the bottom. So I just need to run cables off these, change this to plug as well. This is already on wires. Stick some of these connectors on here on the board. Put the connections in for the battery, and I have a few means to do that. Bought this apparently lower temperature solder. We'll see about that. What else have I got? It is flux solder, but I've cleaned this up with acetone, and just to make my life easier, I'm going to put a bit more flux on it. Can always remove it with some acetone later on if there's too much. I need some wires actually. I need to grab some wire. Before I dismantle the shelf, I'm going to use some black wire, multi-stranded. I have single core. This is single core stranded, and what you'll notice is it's very stiff. Very good for circuits though, and this one's way more flexible. So I think we'll go with the flexible cable for connecting like the GPS, etc. up. I'm going to dry mount it first, just to make sure everything fits. From memory. Never good to use my memory. What should we have? Yeah, that should. I might use. I have to grab some from the other drawers. Instead of directly mount it, what you can use is, if I've got some here, little standoffs. No, I don't. What it allows you to do is then hot plug. Well, not hot plug. You don't want to do that ever with this. It allows you to then unplug it. So if you accidentally damage something, or you need to make another board, you can take the components off easily without using a desolder pump. But anyway, that would go there. Go there. That would go there. Way tidier, huh? Now, on the PCB, I actually took out one of the pins so I could run a track through it, as you can see here. As you can see, yeah. Oh, it was ground. I ran a ground through there. Okay. So I'm going to have to do the same with some cutters, wherever they are. Tools. There we go. Now, let's make sure I remove the right pin. Oh, it's got to be on out positive. Oh, yeah, it's going to be fun. Sorry if I pinged anyone in the eye. So, okay. Good. Is that a 4? Another 4? Now, I never accommodated to fit these sides in. I was actually just going to direct mount them. So if they actually fit, I'll be amazed. As you can see, spin you around. Good. Resistor goes in down here. Resistor goes in here. Temperature probe 1, 2. Oh, they're over here. That's fine. Can put that in there. I think a resistor goes in there. A link goes in there. I hate links. Link goes in there. GoPro power. Just move it back up a bit. GoPro power comes out here, so let's put a 2-pin in there. Headbutt the camera mount. Beautiful. And I just put one of his MOSFETs off. I think MOSFET goes in there. We've got another resistor down here. We've got the heater control output for the, no, not the heat. Yeah, the heater controlled output I think is there. So this has got to carry an amp. So I hope these connectors are rated to that. I need to check. Put you in there. This is the wire cutter control output, not power, just the control for the MOSFET. I've kept it off board because it's going to have to carry a lot of amps, and then we're going to have to connect another battery in here, so you might as well just make it as simple as possible. Simplicity is the key here. We've got another resistor down here, another resistor down there, and that should be it. And then I'll have to create a cable going from here to here, and then take these wires and make it into a connector from here to there as well. And then I'll need to make a I'll need to add some XT connector to the underside and 2 wires off for the main battery input. Need to make a connector for the heater pad, this little guy, to connect in here, and I need to make some wires and then probably make the cable for connecting this up to some output, such as the wire cutter basically. Alright, if it's as easy as that, and I hate playing with these. I don't have a proper crimp tool for it, so it takes a while. So I might fast forward through that part for you. In a nutshell, that's it. Obviously I've got to find all those resistors and make sure I put the right ones in the right place. So let's turn it upside down and knock it all back out. And then flux whatever we're about to do up. I'll just double check that I am in the middle of tidying the shed. That's why I just kicked something. So V in and ground. These are the important ones I want us to make sure. So if we flip it over. Oh yeah, we've got that link wire from here to here. It goes up to here. I think that's a GPS's 5-volt line. No, that's a Satcom's 5-volt line. Ew. Oh no. I'm mad. Let me just work it out. Okay. So it seems like I might have made a mistake. I was going to power the Satcoms off the battery, but it seems like I run it 5 volts to it. Well, it's not a problem because it does take 5 volts in, but we'll see if that's a problem. Because we're putting this is a 3 amp version, but you're going to be putting quite a lot of load through it. You're going to put all of it pretty much through it. It's at 2.02 amps through it. Now, that might be interesting. I guess worse comes to worse, we make another one of these. Or where the battery comes in here, I do something janky and then just run a wire directly off here to the Satcoms. I don't connect that, but we'll try it out. I don't see a problem with that. Okay, so where should we start? I prefer to start with resistors. Hello, rubbish. Start with some resistors first. So let's start with a voltage divider used for working out the voltage to this guy on the battery. Now, where is that? To looking at the laptop screen for inspiration. Okay, so it's 2 resistors. I'm going up here. If I have a pen, I'll just temporarily mark in the resistor points to make my life a bit easier. Now, if I had the Sharpie, the fine one, it'd be a lot easier, but there you go. Resistor, resistor. I know you got a link here, so I'm going to dot that. Same wire. That makes sense. So, sorry if I'm wobbling. First resistor from battery. this guy. I'm pulling him off the breadboard, by the way. There we go. Okay. Now you bend these, you know, you wouldn't have pre-used them or made them very jankily bent. Okay, so let's flip you over. Not off camera view. And find the flux pen I've now lost. There it is. Just a very simple flux pen. As I say, I'm probably overfluxing. And work out where that was now. Ah, it was here. Now, pad size for legs is never big enough for what I like. But, hey, we'll find out in a sec, won't we, when I screw this up. Put that through. I always bend them a little bit out, so it holds them. But, as it's on a flat surface, it's also hard. Clean the soldering iron tip up. Now, this is a chisel piece, it's very big for what we want, but I like it because it's good transfer of heat. And if you're good enough, you can do it sometimes. So we'll pre-tin again, check the soldering irons at the temperature. Now, I've dropped the temperature, so we'll see how this goes. Good. Now another good thing about this is when you're doing like point-to-point testing, if you can take this out of the equation, it is a lot easier. We're going there, like that. See what I mean by the extra height though. And MOSFET is the last component. And my light would be the next one. Automation. Okay, like that. Now I'll flux this up in a sec. Do that before I stick this down. Okay. Now you can plan to put these in lie flat, as you probably saw in the Eagle project that I didn't. I'll put it standing up. Because if you need cooling, shouldn't do. Okay. Mount the mains cable. Good. And that's it. Now, do I risk plugging everything in? Not yet. So next thing I need to do is obviously sort these out. So I have plugs on everything. Just for testing, I need to sort out the temp sensor, sort GPS out, sort the SATCOMs out. Heater pad and cutter, GoPro doesn't matter for that test. I'll do that in a sec. Actually, I might leave that for another video. Leave that for the next one along with the testing. Thanks for watching. Catch you in a bit.